we will be looking into wind force for the model. Generally, the wind force is being considered by using IS 875. This is the code book of part 3. Part 1 is for dead load, part 2 is for live load, and part 3 of IS 875 carries the guidelines regarding wind pressure analysis and wind loading. In IS 875 part 3 you will be having a wind loading, how to apply wind loading, when you should consider wind load for a building, and how we can consider the wind load. So in general instruction, the wind pressure and the forces on building or structures in class 7 have given. The wind load on the building shall be calculated for building as a whole. So for the total structure, for the total elevation, you have to consider the building, not for a single point. If you are having 10 number of floors, for the last floor you will be having high amount of wind. You cannot consider only the 10th floor and start the design or analysis. You cannot do that. Building as a whole you have to take it for all the 4 sides. You have to take at the elevation. Next, it says that individual structural members elements as roof and walls, and the members, what are the members should be taken here is roofs and walls only. We don't need to take column and beam for calculating the wind pressure. Individual cladding units including glazing and their fixture, you have to consider. If number of multi-story structure which are there in metro cities and well developed area, you can see they will be having a glass cladding. Panels will be available on different colors, and these glass panels should be taken and should be considered for wind forces. Why? Because during any wind, these external glass panels will be under high wind pressure and they get affected, and due to their effect, what happens if it is broken, the cost will be much higher. So according to the economic aspect also, you have to consider the wind pressure. Wind force should not break the panels. What is meant by panel is the external glassing. You can make it in glassing or you can make it in panels. They will make it in plastics. Plastic panels are also available. So we should be taking care about that. So these 3 things should be considered for a wind analysis. Okay. Wind analysis also says that if you are building a structure in the lowest part of any area, that is at the crust point, and you can, this is the crust point, wind pressure will be different at different levels. If you are constructing a building at the lowest point of the hill or at the top of the hill, both has some difference, and the intensity of wind will be much higher in the crest point and intensity of wind will be much less in the lowest point of the hill. Okay, so this is upwind and this is called downwind. When the wind is flowing at one direction, the terminology it is given that this is called an upwind, and you will be having the other side which is called the negative pressure. So in the coefficient, when we are taking, you will be having plus value and minus value. What do you mean by minus value is it is the negative pressure which is happening in the wind direction of wind. You can see here that in this portion, if the wind coefficient is taken, it is taken as positive, and at the other side you have to take it as negative. So that is why it is indicated as a downward slope. How to calculate the wind speed? So wind speed depends upon where you are staying. If you are staying in a place where you are having coastal area, where the wind flow will be much higher. So according to the topography, what are the things should be considered for calculating the wind speed is, the Meteorological Department of India have the wind map for India. For a city, you will be having a wind speed. That is, for a Bangalore city, you have 33. Okay, how they are considering that? They are monitoring day by day. They are monitoring throughout the Bangalore and in and around the area. They will monitor, and finally, by taking the average for continuous years of cycle, first one is risk level, which is given in table 1, and that is 6.3.1, and terrain roughness, local topography, and importance factor. These 4 factors influence the 33 meter per second. So in an average for a district, they will be giving it as 33 km per hour. But for a particular building, you have to take these four levels. Okay, let us see one by one. Vz is known as the design wind speed. So wind speed of your building can be calculated by Vb into K1, K2, K3, K4. All the four are a constant. Vz is the design wind speed at a height Z. So you can calculate by using table 1. What is table 1? This is risk coefficient. So this is the first parameter called K1. K1 can be found out by risk coefficient. If you are building a temporary shed, it might be for constructing any building, the workers will make a temporary shed, and for storing the cement, for storing the other materials of building, they will be having a temporary shed. If you are constructing those kind of structures, you can take this case. And if you are building a low degree hazard life property, that is such as isolated tower, wooden areas, farm buildings. So these are all near village area, farm buildings and other residential buildings which have low probability of hazard. Then you can take it as mean probable design life as 25 years. For the temporary sheds, you will be taking it as 5 years, and for these structures, it will be taken as 25 years. And for important buildings such as hospital, communication building, power plant structures, that they are nuclear power plant, mobile towers, and electrical towers, should be considered for 100 years. If you are taking the wind should be, it should be capable of withstanding the wind force for 100 years. And for all general buildings that they are residential building in a city can be taken as 50 years of lifetime. And what is the basic factor of wind speed is 33 meter per second. So I can show you that in IS 875 they have given in annexure A basic wind speed at 10-meter height for important cities and towns. So the wind at 10-meter height is taken here, and since we are in Bangalore, the Bangalore is taken as 33 meter per second. Okay, now this is the basic wind speed at 10-meter height. So if you want to take that, we have to consider this factor. Hence our factor is 33. If you are locating in any other district, you will be having different values. For that respective value, you have to take the wind speed K1 factor, which is being taken as 1 for general structures. And for different structures, you can see that if your risk is much higher, you can see that the factor is being multiplied by 1.05. So according to this risk, you have to take the risk factor. This is a constant. Then what is K2? K2 is being taken as the factor to be obtained design wind speed variation with different terrains. So what do you mean by terrain is you are having 4 classification of terrain. Indian Standard Code says that, and height of the building. If your building is 5-meter height, 10-meter height, as of now our structure is 3 meter and 3 meter. First floor is 3 meter, second floor is 3 meter. So we are coming under the first case, 10 meter. You can build a 500-meter height of a structure. Then the constant will be multiplied by 1.35. If you are in terrain category 1. What do you mean by terrain category 1 is exposed open terrain with few or no obstruction with an average. So this is what I said, a coastal area, sea coast, open sea coast and flat plains without trees. So if you are living in a desert, you will be having sandstorm. If you are living in a seashore, you will be having a high amount of wind. So without the trees, you have to consider your category as number 1. Okay. Now what is category 2 is open terrain with well scattered obstruction with having a height generally between 1.5 to 10 meter. This will be around village area. You will be not having high raised structures. You will be having construction here and there. And if you are living in a dense forest, it is not covered in category 2. But if you are in a village area where you have odd trees and number of houses in spreaded area, example represent airfields. if you are going for any airport, so that is the example for category 2, open parkland and undeveloped, sparsely built up outskirts of town. Okay. Now category 3 is terrain with numerous closely spaced obstruction having a size of up to 10 meter. These areas covers as wooden areas, shrubs, town, industrial areas where you are situated in towns. And if you are in forest and if you are in a dense forest, it is shrubs. And industrial areas are full partially developed areas. So industrial developed areas will be not inside the town, it will be in the borderline of the town. All the industries will be planned in outskirts of the town, not the inside the town. So these areas are taken as category 3. Then last category is terrain with numerous large closely packed obstruction. So this you can take it as a well developed city. Say for example New York City is well developed and center of New York is category 4. And since we are only discussing the India, I am just explaining the dense of the construction. And in a Bangalore, you can take the center of the city, the Majestic or KR Market, it covers under category 4. You have number of obstructions, number of constructions here and there. Okay. So you have to select your category. In our case, whatever we have taken now, our building comes under the height 10 meter and terrain category comes under category 4. We are in center of the city in Bangalore, hence we are taking it as 0.8. Okay. Now, these values have to be imported to the software. The software will be asking different inputs, so these inputs should be taken from here. Then next K3 factor will be topography, where you are constructing your building. If you are having in a sloped area where your building is situated in more than 3 degree of slope, then your K2 value should be 1. K3 value should be 1. If your value of K3 is confirmed in a range between 1 to 1.36, the slope more than 3 degree. If it is in between that, you can interpolate these values. So first thing is not more than 3 degree and second case is more than 3 degree. So in between that you can interpolate from 1 to 1.36. Last category is K4, which is K4 category is importance factor for cyclonic region. Okay. So this is the important factor K4, structures of post cyclone importance for emergency service such as cyclone shelter, hospital, schools. If you are building that, you have to take K4 as 1.3. Industrial structures 1.15. All other structures will be taken as 1. Now our building comes under all other structures. Now let us take these parameters. This is our structure. Let us apply a wind load. Now how to apply a wind load? All the wind should be applied only on the sides and the perimeter of the structure. So in order to take the load, you will be having walls. So as of now, you are not considering the walls here. What you can do is you can add cladding. So you can draw auto cladding. You can go to draw and you can select auto cladding. What is the purpose of cladding is it will create a weightless member and it will be transferring the force to the columns and beams. So you can draw by using that. You can use by floors or by beams or by using the columns. Okay, under the beam type, if we are using, it will automatically cover the building area. So this is what our area. All the area is being applied with the clad. you can see that in the property it doesn't have any self weight. You can see area or mass, area mass equal to 0. There is no self weight here. In order to take the wind load, your structure will be added with cladding. So this cladding will help us to transfer the load to the structure. So we will be connecting to the structure and the load will be taken from here. You can see at all areas the cladding is being applied. After application of this cladding, first we shall define the load. Define, you have to add a load pattern, and here you have to add wind load on x direction. Okay, why we are substituting wind load on x and y direction? So let me give the example. Wind according to IS 875, yes, IS 875 is here. Okay, now you can add the new load. Now new load is being added, wind in x direction, and you can apply wind in y direction, and you click add new load. So we have added two new load which are wind in x direction and wind in y direction. Why you need to apply two wind is, you have the explanation here. Pressure coefficient. In class 7.3, the code indicates that Cp is the pressure coefficient. You will be multiplying the Cp. Different types of Cp is given. If Cp, what do you mean by Cp is external pressure coefficient for walls of rectangular clad building. So right now we have applied auto cladding. If we are having different cases, what is our case? We have to find height by width. What is our height to width ratio? Height is, we are having 3 meter as first floor and 3 meter as second floor. So if we are having total 6 meter, what is the width? H by W. Width of the building is, you can see the building width from plan. Yes, from the plan we can see that this is one width. 4 plus 4 is 8, 8 plus 3 is 11.2, 11.2 plus 1.5, 12.2 and 12.7. So your calculation will be, height is 6 meter divided by, what are your total width? 4 plus 3.2 plus 4 plus 1.5. We will be having the total area, which is 12.7, equal to, if you divide 6 height by width, you will be getting 0.47. 0.47. 0.47 is in between height by width. So height by width ratio is lesser than 1 by 2 is 0.5. So this is our case. We are having 0.47. So first case. If it is more than 0.45 to 1.5, we have to look into this case. Now this is our case. Width building plan ratio. What do you mean by this? This length by width. What is length and what is width? So this is the, in the plan you will be getting length and width. What is our length and width? Let us check here. Length we already know that it is 12.7 and width 3.8. Let us calculate here. Plus, now you have total length as 4 plus 4 plus 3.2 plus 4 plus 1.5. This is our total length divided by width is 3.8 plus 1.47 plus 1.83, which will be 7.1. So if you find the ratio 1.78, this is your value. Length by width is 1.78. Now 1.78 is in this category. You can see that this is 1, this is 3 by 2 is 1.5. Now this is falls under this category. 3 by 2 is 1.5. Since you are getting 1.78, your building comes under this category. Now let us go into this, and wind angle is theta, 0 degree. This is the direction of wind, and this is 0 degree. And if you find theta, if it is 90 degree, it is assumed that wind is blowing in C direction. If wind is blowing in A direction, it is taken as 0 degree, and wind is blowing in C direction, it is taken as 90 degree. For 0 degree, these are the values. At portion A, you will be having a CPE as plus 0.7, and at the opposite side, you will be having the negative wind pressure, which is minus 0.25, and at two sides, you will be having same pressure, minus 0.6 and minus 0.6. You can understand that wherever you have wind flow, you are having plus value, and at all the other sides it will be negative. The same way, if wind is flowing in C direction, that is 90 degree towards this is C. If wind is flowing in this direction, it is taken as, at the portion C, it is taken as plus 0.7, rest of the portions are minus. This is the way to understand. So you have to apply wind force on all the four sides. Okay. Now, the code also suggests that how to find the maximum wind pressure. The average value of these pressure coefficient for some building shapes are given here. So the design wind pressure at height from the ground you have to take, and you have to determine the maximum wind load on the building. How to calculate the maximum wind load? You have to take all the areas. Now you can see that is wind is flowing in this direction or at y direction. We are not knowing at which direction the wind is going to blow. So what we have to do is we have to apply all the sides. All the four sides you have to consider separately, and you have to apply wind. Wind can flow at one direction for some months, and wind flow can change in another direction for some months. So you cannot take only in x direction and find the critical force for finding the analysis. The wind might flow in other cross directions also. So that you have to take all the sides as your wind cases and to find the maximum force. So that is why I have considered the wind in x direction also in terms of y direction. This is what the code also suggests, that the critical direction shown for all the quadrants. You have to take the total load should be calculated for each of the critical direction shown from all quadrants. We have four number of quadrants, and for all four quadrants we have to find. If we are finding wind analysis manually, it is very tedious. Why? Because if wind is blowing here, you have to calculate wind force. If wind is blowing in this direction, you have to again calculate once. For multiple sides, you have to calculate wind force again and again, and it is much tedious to get complete answer. For critical sites, you have to do. So that is why the software gives an advantage. You can just apply the direction, it will automatically calculate. By analysis, you can find which is the critical direction. Okay, in analysis of areas of high load section, that is negative pressure, where you will be having negative pressure, this is what I said. If you are considering one direction, this direction is A. If this is A, rest of the portions will be having leadward. This is called windward, and rest of the sides are called leadward, which will be having negative pressure coefficient. And you have another coefficient. What is that? Coefficient of local effect, which will be used only for roofing sheet, glass panels, They should not be used for entire structural element. So you have CPE here. This is CPE for surface, this is CPE for local. You should not use local CPE for calculation. This will be used only for the corners and for specific purpose only. For overall calculation, you should use these 4 parameters. So let us apply this in our structure and find the solution. So for a designer, code book is very essential. If you are knowing the code book, then you can start designing. Or else the software is a simple box, whatever we are inputting, it will give the answer. It may not be valid or invalid, so it doesn't care about that. Whatever you are applying, it will give the answer. So you have to know the code book in order to use the software judicially. Okay, now let us apply the wind force. We have to define, yes, we have taken wind in x direction, we have to modify load, yes, now we got wind load. So the exposure from extents of diaphragms or exposure from the effect of shell object, you can do it in 2 options. If you are doing in from the shell objects, which we have done now, there are 2 methods of doing wind analysis. Currently we have introduced shell objects. And what is shell object? These are all cladding members, these are all shell objects. Currently we have used this method, and wind force can be found out by using diaphragm method also, which I will discuss tomorrow. And as of now, what is our basic wind speed is 33 for Bangalore, and we have to take it from here for whatever city you are. If you are coming from Madurai, you have to take 39. If you are coming from Bangalore, you have to take 33. The maximum wind speed is you are having at these places near seashore. You can see Kozhikode and Cochin, Kanpur. You can see Kolkata is near the West Bengal. So you are having 50 km per hour. Nellore is near seashore. It is having 50 km per hour. Visakhapatnam, Vijayawada, the coastal areas. That is why the wind speed is much higher. So according to the place, we have taken as 33. And terrain category is 2. Which category we have to take? This is terrain category. Now, what is our terrain now? Different terrains. I have said that the last case it will come. Last case is heavily populated area. Since Bangalore is a heavily populated area, category 4 with numerous large closely spaced obstructions equivalent to aerodynamic roughness. You will be taking this as category 4, and our building is less than 10 meter height. So we have to take 0.8. So here we shall substitute terrain category as 4, and importance factor. Importance factor is what kind of building we are using. We are all other structures which is having 1. We are not building any industrial building, school or communication tower, etc. We are only coming around other structures. So let us go here. Importance factor is 1, 1.53. Here we will be selecting 1. Risk coefficient K1. How to use risk coefficient? K1, risk coefficient. Which kind of building we are using? All general buildings which will be having a year of 50 years of time. So these are all temporary sheds and farm building, power plant, such as your example. And if you need a lifetime of 50 years, 100 years, you have to choose your lifetime, and for 33 km per hour, your K1 is 1. So let us select K1 also as 1, and topography factor, let us select K3. What is K3? K3 is topographic factor, how you are placing your building, where you are constructing your building. Is your building is located in a slope which is having 3 degree or it is lesser than 3 degree, and we will be looking into that. So since we are assuming that land slope is much lesser than 3 degree, it is, let us assume that it is in flat land, hence we can take K value as 1. K value as 1. Now exposure height is story 2, this is the maximum story, and bottom story is base. Let us press OK here. Let me use wind in y direction, modify lateral load from shell objects, same thing for y direction 33, category is 4, this is 111, rest of things are okay. Okay, now I have indicated for both the cases. Now press OK. Now define load combination. Here we have to indicate the load combination. Let us delete the existing combo and add new combos, convertible to user combination. You can see that now how many load combinations automatically came. This is the earlier combination, 1.5 times dead and 1.5 times super dead load. Now next combination is, you can see that it is 1.5 times dead live and super live load, and 1.2 times dead live and super dead load. So these are the combinations in wind in x direction, you can see, and wind in y direction also you can see the combinations. Now automatically it is being generated. You have to apply the force. How to apply force? Assign. Hence you are indicating wind pressure coefficient. You have to apply the wind pressure coefficient here. Now this is at the direction of A. You can see here that from the code book, this is our building and this is the side of A. For A portion, your pressure coefficient is plus 0.7. So let me take it as, for A coefficient 0.7. This is at windward. So how many places I have to click? 1, 2, 3, 4. So 4 shells I have selected. You can see here. Now I have to apply the wind. Apply, and wind load is being applied. You can see that 0.7 times wind. Now at the opposite side, you are assuming that wind is flowing in this direction. So you can see that the coefficient at the rest of the sides will be very less, lesser than 0.7. 0.7, rest of the things are 0.25, 0.6 and 0.6. So this is one case. Now opposite leadward side is B. B is what? This is point A and this point B. Point B is 0.25, minus 0.25. Let us apply that at the opposite direction. So here you should apply the wind force. Why? Because at the first floor you will be having the same amount of wind. These are the two portions you will be having wind. So plus 0.7, apply, you have applied now. Now let us rotate this. Now at leadward side you will be having the same wind. So these are the leadward sides, 1, 2, 3, 4, 5. Now at these 5 areas, and also you have the small portion, at these areas you will be having the leadward side, which is minus 0.25, which is the leadward side. You have to select that and apply. Now we have applied load at windward side and as well as leadward side. Wind is applied at this direction. Now rest of the sides will be having rest of the C and D side. What is C is minus 0.6 and minus 0.6. C and D side will be having minus 0.6. Since we will be not applying for C and D side. Why? Because we will directly apply the load at this side, and this will be windward and another portion will be leadward. So in wind direction we have applied. So let us press OK. Now wind in Y direction. Now this is our Y direction. Let us take that. Since this is our X direction, you can see that this is the axis, X axis. This is our X direction and this is our Y direction. Okay, let us anyhow change the direction afterwards. No issues. If we are assuming load is coming, wind load is coming in this direction, we can assume it as, if the wind load is 90 degree, you can see that if it is 90 degree, you can apply at C portion is 0.7, at rest of the portions as the remaining. Let us apply this portion as 0.7. This as 0.7, 0.7. This is the windward direction. Apply. Now the opposite side of this will be leadward direction. Now this will be the leadward. 1, 2, 3. 3 edges are selected, which will be leadward. At D side you will be having minus 0.1. So let us provide minus 0.1, and this is at leadward or side constant. Let us press apply. Now you have applied all the cases for both windward and also leadward. If the wind is applied at this direction, you will be having the leadward as the opposite. Your answer is not going to much vary, hence we are not going for all the 4 directions. In this direction, we are considering the same will be the opposite. So for calculative purpose, we are taking only 2 directions and opposite will be the same. So we have applied our wind loads. Now let us analyze the structure. Analyze, check model. Now our model is okay. Let us do the analysis. Set the load cases. What are the load cases which will be run? We know that wind in X direction and Y direction, dead load, live load, all the load cases are shown. Now let us run the load. Wind load analysis is over. We can see the deformation shape. If we apply for dead load, we can see that we will be having downward deflection, and the maximum is 0.948, which is in mm for only dead load. And if you look into live load, if I am applying, we can see much lesser deflection is there. Maximum is 0.742, and if you apply super dead load, the structure is much deflected here, and you can see 2 plinth beam are deflecting, might be large and visible, but it is very mere, minus 0.791 mm. If we look into wind, which we have applied now, we are applying, you can see that it is deflected in one direction. Wind in Y direction if we are applying, so we have applied wind in Y direction. So that is why you can see that, you can see the difference. If I am starting to make the animation, you will be getting a good understanding in y direction. We have provided the wind in y direction. You can see that when wind is passing, you are experiencing a y direction displacement and a torsion. Why torsion is been present in this structure is, you can see at the first floor one part of the building is only occupied, rest of the portions are not occupied. Hence you can see that when the wind is being applied at one side, you are experiencing a torsion. This torsion will be applied to all the column, so all the column experience the torsion due to this. If you are having a symmetrical section, you will be not experience this, and you will be experiencing only in y direction. But if you apply in x direction, let us see the animation. You can see in the direction of which the force is being applied, the deflection is occurring. This is for just an understanding. Okay. Now let us check the reactions. To stop the animation, let us look into undeformed shape. Let us find the reactions now. You know that for dead load we have reactions, and let us look into the plan, base, apply. You can see the maximum force is 195. Here we had the floor displacement is also maximum, column is also having 195 of forces, and moment is very much less, around 15 kilonewton, and here you are having around 17. Okay. Now at the wind load, let us check for wind load. We have already checked this. If we are checking for wind load, you can see that the force in x, y and z direction, you can see a small number of wind force is being applied. In f of x, you can see 1, 1, and let us zoom this. So that we can look it freely. Yes. Due to the wind, you can see much lesser force which is there in these columns, and moment in x, y, z direction is also less, nearly 0.0. In y direction, you are having 0.4. This is only the considerable value. And if you check the next two base, around 1.69, this is the maximum z force, that is, and you are having x and y is also very negligible. You can see f of x and f of y here as 1.5 and 1.3. This is the maximum value. Yes. And you are having around f of z is also minimum. Okay. Now let us apply wind load in y direction. We apply, we can see that moment is also very less and force is considerably less, 1 kilonewton per meter. There is no much wind force which is going to affect this structure. Also we can check for load combinations, which is the best and worst load combination, we can check for that. You can see that around 547 kilonewton of force is being applied at y. You can see the moment at x and y direction. For all the cases you can look and analyze. This is the worst case, that is 615 kilonewton of force, and rest of them are nominal. You will be having moment. This is the highest moment, 44 and 30 as moment in x direction and moment in y direction. Z moment is very less now. This is the way to calculate the reactions, and you can check the mode shape also. Mode shape will be much useful when you are doing for dynamic analysis. In 3D you can view this. This is second mode shape, 3, 4, 1. These are the different mode shapes for a structure. This will be useful when you are doing earthquake analysis. So we have 12 number of modes. Dynamic load is lateral loads and time variant loads are called dynamic loads. If the load is changing in a time, example wind will blow at a particular speed in one state of time. At night you will be having high wind speed. At certain months you will be having different wind speed, like that. It changes according to time. But dead load, live load, super dead load will not going to change. It is constant. So what are dynamic load is time variant load. Due to time, if you are having lesser or higher loads, then it is known as time variant. These are the bending moment. You can check it. Along with the load, you can see the bending moment and shear force. Both the column and beam will be having the shear force. So in detail you can right click that and view this. So this is for today's